Picture this. While every other automaker is scrambling to catch up to Tesla's 10-year head start in electric vehicles, Elon Musk just dropped a bombshell that could make their competition obsolete overnight. Tesla's latest motor technology breakthrough isn't just an incremental improvement. It's a complete reimagining of electric vehicle efficiency that could extend your driving range by hundreds of miles while slashing manufacturing costs in half. If you think you understand electric motors, prepare to have your mind blown, because what Tesla just revealed changes everything we thought we knew about electric vehicle propulsion. For over a decade, Tesla has been the undisputed king of electric vehicle efficiency. While traditional automakers were still figuring out how to make electric cars that could drive more than 50 miles, Tesla was already perfecting motors that could propel a Model S over 400 miles on a single charge. But efficiency has always been Tesla's obsession, and their latest innovations prove they're nowhere near finished pushing the boundaries of what's possible. The heart of Tesla's efficiency revolution lies in their motor technology evolution. Most people think all electric motors are basically the same. Just spin some magnets near some copper wire and voila, you've got motion. But the reality is far more complex, and Tesla's approach has always been fundamentally different from everyone else in the industry. Traditional automakers typically use permanent magnet synchronous motors, which rely heavily on rare earth elements like neodymium and dysprosium. These materials are expensive, environmentally problematic to mine, and subject to supply chain disruptions, since most of them come from a handful of countries. Tesla initially took a different path with their Model S and Model X, using induction motors that contained no rare earth elements at all. Induction motors work by creating a rotating magnetic field in the stator that induces currents in the rotor, causing it to spin. The beauty of this design is its simplicity and durability. There are no permanent magnets to demagnetize at high temperatures, and the motors can handle extreme conditions without degradation. However, induction motors are typically less efficient than permanent magnet motors, especially at lower speeds and partial loads. When Tesla introduced the Model 3, they made a strategic shift to permanently excited synchronous reluctance motors, also known as permanent magnet motors. This wasn't just about following industry trends. It was a calculated decision based on efficiency optimization for their specific use case. The Model 3's mission was to be Tesla's mass market vehicle, which meant maximizing efficiency was crucial for both range and cost considerations. But here's where Tesla's engineering brilliance really shines through. Along with the new motor design, Tesla incorporated silicon carbide power electronics and improved lubrication, cooling, bearings, and gear design. This holistic approach to the entire powertrain system allowed them to achieve remarkable efficiency gains that went far beyond what the motor improvements alone could deliver. Silicon carbide represents one of the most significant technological leaps in power electronics. Traditional silicon-based inverters and power controllers have limitations in terms of switching speed, efficiency, and heat generation. Silicon carbide operates at much higher voltages with significantly lower losses, meaning more of the battery's energy actually reaches the wheels instead of being lost as heat. The impact of these improvements is staggering. Tesla turned a 4% motor efficiency improvement into a 10% range increase. This might seem like magic, but it demonstrates how interconnected all the systems in an electric vehicle really are. When you improve motor efficiency, you reduce heat generation, which reduces the load on cooling systems, which saves more energy for propulsion. When you improve inverter efficiency, you reduce electrical losses throughout the entire power conversion process. Tesla's latest breakthrough goes even further. Tesla announced they will create a permanent magnet electric vehicle motor with zero rare earth elements. This represents a fundamental shift that could revolutionize the entire electric vehicle industry. By eliminating rare earth elements, Tesla can reduce costs, improve supply chain security, and minimize environmental impact while maintaining or even improving performance. The key to this breakthrough lies in advanced materials science and manufacturing techniques. Tesla has developed permanent magnet motors with carbon wrapping, which allows them to achieve the magnetic properties they need without relying on traditional rare earth magnets. Carbon fiber wrapping provides exceptional strength and allows the rotor to spin at incredibly high speeds without failing, which is crucial for the high-performance applications Tesla demands. This carbon-wrapped motor technology first appeared in the Model S Plaid, where it enables the vehicle to achieve ludicrous acceleration figures while maintaining efficiency. The carbon fiber reinforcement allows the rotor to withstand the tremendous centrifugal forces generated at high RPMs, enabling power densities that would be impossible with conventional construction techniques. But the real game changer is Tesla's next-generation powertrain architecture. The company's next drive unit will have 75% less silicon carbide, will be compatible with any battery chemistry, and will feature a 50% reduction in factory footprint. This represents a complete reimagining of electric vehicle manufacturing that addresses cost, flexibility, and scalability simultaneously. Reducing silicon carbide usage by 75% might seem counterintuitive given how much Tesla has promoted this technology, but it actually demonstrates their engineering sophistication. By optimizing the entire system architecture, they can achieve the same or better performance with dramatically less of this expensive material. This reduction in silicon carbide usage directly translates to lower manufacturing costs, which means more affordable electric vehicles for consumers. The compatibility with any battery chemistry is equally revolutionary. Current electric vehicle powertrains are typically optimized for specific battery types, which limits flexibility and increases complexity. Tesla's new architecture can work with lithium iron phosphate, nickel manganese cobalt, solid-state batteries, or whatever chemistry emerges in the future. This future-proofs their vehicles and manufacturing infrastructure in ways that competitors simply cannot match. Manufacturing efficiency improvements are where Tesla really separates itself from traditional automakers. Tesla has maintained about 30% more energy efficiency than competing electric cars for over 10 years, but their latest technologies show they're targeting even more dramatic improvements. The new Tesla technologies show they are on track to achieve 1.5 to 1.6 kilowatt hours per mile efficiency in the Semi and high efficiency in all of their other vehicles. To put this in perspective, most electric vehicles today consume between 3 and 4 kilowatt hours per mile. Tesla's current vehicles typically achieve 2.5 to 3 kilowatt hours per mile, which is already industry-leading. But reaching 1.5 to 1.6 kilowatt hours per mile would represent a doubling of efficiency compared to most competitors. This level of efficiency would make electric vehicles dramatically more practical and affordable to operate. The implications extend far beyond just better range numbers. Higher efficiency means smaller battery packs can deliver the same range, reducing vehicle weight and cost. It means faster charging times since you need less energy to travel the same distance. It means lower electricity costs for consumers and reduced strain on the electrical grid as electric vehicle adoption accelerates. Tesla's approach to thermal management also plays a crucial role in their efficiency gains. Traditional electric vehicles often struggle with thermal issues, especially during fast charging or high-performance driving. Tesla's integrated cooling systems for motors, inverters, and batteries work together to maintain optimal operating temperatures under all conditions. Better thermal management means components can operate more efficiently and last longer. The manufacturing innovations are equally impressive. Tesla's vertical integration allows them to optimize every component for their specific applications rather than using off-the-shelf parts designed for multiple manufacturers. They can design motors, inverters, and control systems to work together seamlessly, achieving efficiencies that would be impossible with a traditional supplier-based approach. Quality control in motor manufacturing is critical for achieving maximum efficiency. Tesla's precision manufacturing techniques ensure that air gaps between rotors and stators are perfectly uniform, magnetic fields are precisely aligned, and bearings operate with minimal friction. These might seem like minor details, but they add up to significant efficiency improvements when multiplied across millions of vehicles. Tesla's software integration also contributes to motor efficiency in ways that are often overlooked. Their motor control algorithms continuously optimize power delivery based on driving conditions, battery state, temperature, and dozens of other variables. This real-time optimization ensures that the motors always operate at peak efficiency regardless of circumstances. The predictive capabilities of Tesla's system are particularly impressive. By analyzing driving patterns, route information, and vehicle state, the system can pre-optimize motor operation for upcoming conditions. If the navigation system knows you're approaching a hill, it can adjust motor parameters in advance to maximize efficiency during the climb. Regenerative braking represents another area where Tesla's motor technology shines. Most electric vehicles can recover some energy during braking, but Tesla's motors are optimized to maximize regenerative efficiency across a wide range of speeds and deceleration rates. This not only improves overall efficiency, but also reduces wear on traditional friction brakes. The integration between motor control and battery management is seamless in Tesla vehicles. The motor controllers communicate directly with the battery management system to optimize power delivery based on battery temperature, state of charge, and cell balancing requirements. This prevents the motors from demanding more power than the batteries can safely deliver while ensuring maximum performance when conditions allow. Looking toward the future, Tesla's motor technology roadmap includes even more ambitious improvements. Wireless power transfer, advanced magnetic materials, and novel motor topologies are all areas of active research and development. The company's massive investment in research and development ensures they'll continue pushing the boundaries of what's possible in electric vehicle efficiency. The competitive implications of these advances cannot be overstated. While other automakers are still struggling to match Tesla's current efficiency levels, Tesla is already developing technologies that will make today's electric vehicles look primitive. This technological gap is widening rather than narrowing, despite billions of dollars in investment from traditional automakers. Supply chain considerations also favor Tesla's approach. By reducing or eliminating dependence on rare earth elements, Tesla insulates itself from supply disruptions and price volatility that affect competitors. This strategic advantage becomes more valuable as electric vehicle production scales globally and competition for scarce materials intensifies. Environmental benefits extend beyond just zero tailpipe emissions. More efficient motors require less electricity generation, reducing overall environmental impact. Eliminating rare earth mining for motor magnets addresses one of the most problematic aspects of electric vehicle production from an environmental perspective. The economic impact of Tesla's motor innovations ripples throughout the entire automotive industry and beyond. More efficient electric vehicles accelerate adoption by reducing total cost of ownership. Lower manufacturing costs enable price reductions that bring electric vehicles within reach of more consumers. Reduced material requirements help stabilize supply chains and pricing for the entire industry. Tesla's motor technology represents far more than incremental engineering improvements. It's a fundamental reimagining of electric vehicle propulsion that addresses efficiency, cost, manufacturability, and sustainability simultaneously. While competitors focus on catching up to where Tesla was 5 years ago, Tesla continues pushing the boundaries of what's possible, ensuring their technological leadership for years to come. The next time you see a Tesla silently accelerating past you on the highway, remember that you're witnessing the result of over a decade of relentless innovation in motor technology. What looks simple on the surface represents some of the most sophisticated engineering on the planet, optimized for efficiency in ways that most people never see or understand. Tesla's motor technology isn't just about making better electric cars. It's about fundamentally changing transportation forever, one incredibly efficient electron at a time.